Okay, so onward. So then it asks us to go ahead and measure the width of the volcano north to south at an elevation of 4,400 feet going through the peak. Now, calculate the volume of Mount St. Helens above 4,400 feet using the equation to calculate the volume of a cone. So remember that a stratovolcano is pretty similar to a cone. And so, depending on what elevation you start at basically from a different cardinal directions, like opposite cardinal directions, you'll get some sort of cone-shaped idea. So we'll use the equation for finding the volume of a cone, which is 1/3 times pi times radius squared times the height. In which case, the radius squared we will find depending on what distance we get measuring from the 4,400 feet mark north to the 4,400 feet mark on the south. And then the height is going to be equal to the peak elevation minus the 4,400 feet, because that is where we're starting. That is going to be, in theory, the base of our cone, right? All right, so let's go ahead and do that. So if we have our map, this is what we had before. Before we used to have A and B here, but those 2 points are not at 4,400, right? Those were at random elevations that were 2 miles from the peak. Now we need to extend this all the way to the 4,400 mark. So due north, 4,400 index contour is right here. So we extend it a little bit. Cool. And then, sorry about that. And then due south, the 4,400 index contour, let's see, this is 4,000. And we know that there's 400 going upwards every index contour. So this one right here is 4,400. Which means that if we lengthen this up onto here, we get the 4,400 foot mark due south. So that distance is now a little bit bigger than the 4 miles, right? So I already measured it, thankfully. And I have it going about 1, 2, 3, 4, and about 4.5 miles. So that distance is 4.5 miles from north to south. However, that is not the radius, right? That is the diameter of that cone. So the radius is just simply half of the diameter. So if we follow the formula again, radius is going to be half of 4.5. So we're going to call it 2.25 squared. Just going to do this. And then times the height. So we know that the height, again, is going to be the elevation difference between the peak height minus the 4,400 foot elevation mark. So 96.77 was the peak, the height of the peak, minus 4,400 feet. And that's going to give us some, oh, sorry, this is in miles. I should clarify that. Some X amount. So later on, you'll see that in the questions, I ask you to find the volume of Mount St. Helens in cubic miles. And within this tip explanation, I tell you to determine the height that it takes, the peak elevation minus the 4,400 feet, and then divide it by the 5280 to convert it to miles. So I want this overall units to be in miles. So I want to change this to miles. So I say 1/3 times 3.1416 times 2.25 miles squared times, so we can do the subtraction first. So 96.77 minus 4,400 is 52.77. And again, remember that we have to divide that by the number of feet in a mile. So 52.77 divided by 52.80, so that's convenient, pretty close to 1. We have 0.99943, just to be a little bit more exact. And this is in miles. All right, so now we have all our values. So we just simply have to go ahead and plug and check. So we get, sorry about that. So we get that 2.25 squared is equal to 5.0625. I'm going to go ahead and change that right here, just for clarity's sake. 625. So that times 0.99943 times 3.1416 times 1/3. So the volume in cubic miles, right, this is miles squared, it's going to be 5.3 miles cubed. Okay, so hopefully that makes sense. Again, remember that units, as you're multiplying them, they're also multiplying one another. So in this case, because this was the radius squared, you get miles squared, and then you're multiplying that times the height, which is also in miles, so you get miles cubed when you're calculating for the volume of that cone-shaped volcano. Excellent. So that takes us through question number 4. All right. Good, so now what comes next is actually working on the second map. So print that second map that you see below. That's the topographic map of Mauna Loa, and then you're going to answer questions that are pretty similar to the ones that we just did. So this map, it's slightly easier to read, but at the same time it's fainter, so good luck. And the measurements are different. So these squares that you see subdividing the map are not 1 mile like they were for the Mount St. Helens map, but these are equivalent to 6.25 miles in each direction, okay? So there's 6.25 miles from here to here, and there's 6.25 miles from here to here. Okay, so that will facilitate things. To know that will facilitate things as you go onward. So questions 5 you can do on your own now. Questions 6 and 7, I believe that you guys can do this on your own again. You just have to measure things like we just did for the previous one. And then lastly, you'll do question 8, which is what we just did for the volume in Mount St. Helens. You'll do the same idea. Okay, excellent. So we're done with part 1 as we do that. We continue on to part 2. So part 2 is fairly straightforward. Most of it is just reading information that I have for you. So what you're going to do is we're going to analyze the volcanic eruptions and seismic activity. So how are they related? So we're going to navigate to the following website that I have right here for you. It's a USGS website, and it's a fact sheet basically on Mount St. Helens on the 1980 eruption. So you can go to that. So here's the fact sheet, read through it, and then you'll be able to answer the following questions. So questions 9, 10, 11, and 12 should pretty much be all on that fact sheet, the answers to them. Then you're going to navigate the following website to read about Mauna Loa in the 1984 eruption. So you'll go to that. It's also a USGS fact sheet. So there's, or not just fact sheet, there's a lot of information on this in this case. Pretty cool. And based on that, you'll be able to answer questions 13, 14, 15, 16. All right. So now I'll help you a little bit with this next part. So use the earthquake data provided to you in the table below, so this table, to plot on the graph paper below. So that would be this graph paper. Okay? So what you're going to need to plot on that graph is going to be the number of earthquakes for each listed day from both of the eruptions. Those eruptions being Mount St. Helens and Mauna Loa. Okay? So, in your graph paper, you're going to have the x-axis be the day number, and then the y-axis be the earthquakes per day. So, and I'll go through that with you. So plot the data for both volcanoes on the same graph paper. So maybe just use different colored pens or pencils or whatever. And then do not plot data for dates or days that are not included in the table. Okay, so don't just assume, simply plot those that are included in the table. Okay, and this is just a specification of what you are seeing in the table itself. So let's go ahead and plot those, or a few of those together. All right, so if this is our graph paper, again, we want the day number to be the x-axis, and we want the y-axis to be the earthquakes per day, okay? So I'm going to help you with the first one. Let's see. All right, so the first data that we have is that on day 1, there was 1 earthquake per day. So obviously that's going to be pretty tiny over here. Day 3, there was 1 earthquake. So if we follow along the graph paper, this is day 5, so day 3 is about here. Again, you can do this with more detail if you have it printed. Okay, on day 6, we have 32 earthquakes. So day 6 is about here. And we have 32 earthquakes, so a lot more earthquakes. So this is 30 mark, so 32 is about here. Okay, day 10, we have 136 earthquakes. So day 10, 39 earthquakes. So 130 is right here, 139 will be right here. Day 12, we have 72 earthquakes. So day 12, about here, we have 72 earthquakes. So 70 is here, so about here. Day 16, we have 82 earthquakes. This is the last one I'll do with you. Okay. And you continue. So you would continue plotting the day numbers versus the earthquakes per day that you obtained. So pretty straightforward. You do the same thing with the Mauna Loa earthquakes. I would do them in different color, just so that you are clear as to which one is which. Okay, so I'm gonna exit from here. So once you have done that, you can continue on to the following questions. So question 17, how did the number of earthquakes per day change over time for Mount St. Helens after the large number of earthquakes on March 29th? So you can even just analyze that from the data, but you see that on March 29th, which is one of the ones we plotted, we had 139 earthquakes, and you can see what is happening as you go onward in days to the number of earthquakes. All right. Question 18. How did the number of earthquakes per day change over time for Mauna Loa? So you do the same idea, analyze the data or your graph paper or both just to have clarification, and you'll be able to answer that question. Okay, so then, prior to 1980 eruption of Mount St. Helens, most of our knowledge of volcanic eruptions was based on studies on Hawaiian volcanoes. Do you think that seismicity data could have been used to reliably predict the eruption of Mount St. Helens on May 18 of 1980? Why or why not? And then basically the same question, but for Mauna Loa on March 25th of 1984. Why or why not? So you will think about that based on what answers you get on these two questions, basically, and what you see in your table analysis and on your graph paper analysis. And then once you have answered the questions, I do want you to consider something based on your observations. So how is it that stratovolcanoes and shield volcanoes compare in size, in seismic activity and earthquake activity, and on explosiveness of those eruptions? And maybe that will hint you, or that will perhaps make a little bit more sense of why it is that seismicity is tied to volcanoes and more so in a certain type of volcano than other. So you start piecing 1 and 2 together based on what we saw in the last chapter and on this chapter for volcanic activity. So with that, that is all I have for you in terms of a helping guide in this lab. If you need any other help, I am happy to answer any questions you have through email. Or if you need to set up a time to talk to me, we can definitely do that through Blackboard Collaborate Ultra. So just let me know. I'm happy to help. As always, have a good week and best of luck as you go throughout this lab.